In the spring of 1955, two locomotives belonging to the French National Railway Company were quietly being prepared for an attempt that nobody outside a small circle of engineers and government officials had been told about. France, in the mid-1950s, was a country still rebuilding from the devastation of the Second World War, still negotiating its place in a world where new technological powers were redefining what national prestige meant. The railway had once been the clearest expression of that prestige, the visible proof that a nation possessed, the industrial sophistication to build machines that moved people and goods faster and more reliably than its neighbors. By 1955, with aviation advancing rapidly, and with German and American railway engineering pursuing their own ambitious programs, France's National Railway Company, the SNCF, understood that a record attempt was not simply a technical exercise. It was a statement, deliberately timed and deliberately controlled, about what French engineering could still accomplish in a world that was rapidly forgetting how recently the country had been occupied and broken. The locomotive at the center of this story was numbered CC 7107, a member of the CC 7100 class of electric locomotives that the SNCF had introduced earlier in the decade as the backbone of its electrified express passenger services. The CC 7100 class represented a significant engineering achievement in its own right, even before anyone began discussing record attempts. The wheel arrangement, denoted by the double C in its classification, meant two sets of 3 powered axles, a configuration that gave the locomotive substantial traction capability, while distributing its weight across enough wheels to keep the axle loading within acceptable limits for the French rail network. The class had been designed for sustained high-speed running on the newly electrified main lines that France was building out across its territory, lines that used the 1500-volt direct current system that had become the standard for French electrification in this period. What distinguished CC 7107 from its sister locomotives in the class was not its basic design, which it shared with the other members, but the specific modifications that SNCF engineers applied to it in preparation for the record attempt. The locomotive's gearing was altered to favor speed over the tractive effort that the standard configuration prioritized, a trade-off that meant the modified locomotive would be less useful for ordinary express passenger duties, but considerably more capable of sustained high-velocity running on the specific stretch of track that had been selected for the attempt. The traction motors were uprated where engineering analysis suggested headroom existed. The overall electrical system was pushed toward the upper limits of what the components could tolerate, limits that the engineers understood with considerable precision because French electrical engineering in this period had reached a level of sophistication that allowed for exactly this kind of careful, calculated pushing of boundaries. The stretch of track chosen for the attempt ran through the Landes region in southwestern France, a section of the line between Bordeaux and the Spanish border that offered the long, straight, well-maintained track that a sustained high-speed run required. The SNCF had spent considerable effort preparing this section specifically for the test, reinforcing the catenary system that supplied the electric current, checking and rechecking the track geometry, and coordinating the kind of operational precision that an attempt of this magnitude demanded. Nothing about the preparation was casual. Everyone involved understood that pushing an electric locomotive towards speeds that no railway vehicle had previously sustained carried risks that no amount of careful engineering could entirely eliminate. On the 28th and 29th of March, 1955, CC 7107 and its sister locomotive in the parallel BB 9000 class program ran their record attempts on the prepared section of track. The crews who operated the locomotives during these runs were chosen with the same care that had gone into every other aspect of the preparation. Experienced drivers who understood both the technical demands of the attempt and the psychological discipline required to operate a machine at speeds that exceeded anything in their previous experience while maintaining the precise control that safety at those speeds demanded. CC 7107 reached a maximum speed of 331 kilometers per hour during its record run, a figure that represented not merely an incremental improvement over previous railway speed records, but a genuine leap into territory that railway engineering had not previously demonstrated as achievable. The speed, converted to the units more familiar in some parts of the world, exceeded 205 miles per hour, a figure that placed an electric locomotive running on conventional steel rails into a performance category that aviation enthusiasts of the period might have found surprising to associate with ground-based rail transport. The achievement of the speed record was immediate and unambiguous. What followed in the hours and days after the record runs were completed revealed something that the celebratory headlines did not initially capture, something that the engineers who had prepared CC 7107 understood with a clarity that the public announcements chose not to dwell on. The locomotive had been pushed to a speed that revealed with brutal physical honesty exactly where the limits of the technology actually sat. The post-run inspection of CC 7107 found evidence of stress throughout the locomotive's mechanical and electrical systems that confirmed what the engineering team had suspected might occur but had hoped to avoid. The pantograph, the mechanism that maintained electrical contact between the locomotive and the overhead catenary wire, had experienced violent oscillations at the extreme speed, oscillations severe enough to produce visible damage to both the pantograph itself and to sections of the catenary system it had been drawing power through. At 331 kilometers per hour, the aerodynamic forces acting on the pantograph exceeded what the mechanism had been designed to handle, with the margin of safety that normal operation assumed. And the contact between pantograph and wire became, in the final stretches of the highest speed running, an intermittent and violent process rather than the smooth, continuous contact that electric traction depended upon. The wheel and axle assemblies showed wear patterns consistent with the kind of dynamic loading that occurs when a heavy locomotive is pushed to speeds well beyond its design optimum. The bogies, the pivoting wheel assemblies that allowed the locomotive to navigate curves while distributing its weight across the rail, had absorbed forces during the high-speed running that the engineer's subsequent analysis described in terms that, while never publicly dramatized in the way that comparable findings might have been treated in a less carefully managed press environment, left no doubt among the technical staff that CC 7107 had been operated at the absolute edge of what the locomotive structure could tolerate without catastrophic failure. What makes the story of CC 7107 distinct from some of the other extreme speed locomotive stories of the 20th century is the specific institutional response that followed the discovery of this stress damage. The SNCF, unlike some railway organizations facing comparable post-record revelations, did not attempt to minimize or obscure what the engineering inspection had found. The technical staff who had prepared and operated CC 7107 understood that the record had been achieved at a cost to the locomotive's structural integrity that made any further attempt at those speeds with that specific machine in that specific configuration an unacceptable risk. The record stood. It would stand, in fact, for 34 years before a subsequent French TGV set finally exceeded it under entirely different technological circumstances. But CC 7107 itself was never again asked to approach the speed it had achieved on that day in March 1955. The locomotive was returned to a modified configuration following the record attempt, its gearing and electrical systems adjusted back toward the parameters that made it suitable for the kind of sustained, safe, repeatable operation that ordinary passenger service required, rather than the extreme single event performance that the record attempt had demanded. It continued in service on the SNCF network for years afterward, performing the unglamorous and entirely necessary work of hauling express trains at conventional operating speeds, its record-setting achievement becoming a historical fact attached to a machine that spent the overwhelming majority of its working life doing nothing remarkable at all. The significance of what CC 7107 demonstrated in 1955 extended well beyond the specific number that the speedometer recorded on that day. The record run, and more importantly, the careful post-run analysis of exactly what that speed had cost the locomotive's physical structure, provided the French railway engineering establishment with empirical data of a kind that no theoretical calculation could fully substitute for. The engineers now understood, with a precision grounded in actual physical evidence rather than projection, exactly where the failure points sat in the technology of the period. They understood what the pantograph and catenary interface could and could not tolerate at extreme speed. They understood what the bogie and wheel assemblies experienced under the dynamic loading that high velocity imposed. This knowledge, hard-won through the specific risk that the 1955 record attempt represented, became foundational input into the next generation of French high-speed railway engineering, informing decisions that would eventually produce the TGV system that transformed French passenger railway operation in the decades that followed. There is a particular value in understanding CC 7107's story as something more complicated than a simple triumph, more complicated than the straightforward narrative of national engineering achievement that the SNCF's public relations apparatus presented to the French public and to the world in 1955. The locomotive achieved something genuinely remarkable. It also revealed, through the careful and honest inspection that followed its achievement, exactly how close that remarkable achievement came to exceeding what the underlying technology could safely sustain. The distance between celebrated success and structural failure in CC 7107's case was measured in the specific stress fractures and wear patterns that the post-run inspection documented, evidence that the locomotive had not simply achieved its record with margin to spare, but had approached, in certain of its systems, the actual limits of what 1950s electric railway technology could survive. CC 7107 has been preserved. It exists today in the collections maintained by French railway heritage organizations, a physical artifact of the specific afternoon in March 1955, when French railway engineering pushed itself to a speed that no one had previously achieved on conventional rails, and discovered, in the process, exactly what that achievement demanded of the machine that delivered it. The locomotive does not run at anything approaching its record speed today, and it has not done so since the inspection that followed the record run revealed what that speed had cost. It survives instead as evidence of a particular kind of engineering honesty, the willingness to celebrate an achievement while simultaneously and carefully documenting exactly what that achievement had nearly destroyed. The record stood for 34 years. The locomotive that set it survived for decades more, not because it was indestructible, but because the people who built it and tested it and inspected it afterward understood the difference between what a machine could achieve once under perfect and carefully prepared conditions and what that same machine could sustain in ordinary, repeated working service. CC 7107 taught French railway engineering that distinction in the most direct way possible, through physical evidence that no amount of celebration could be allowed to obscure. It went faster than any railway vehicle running on conventional rails had ever gone before. It nearly broke itself, proving it could. And the engineers who built it had the discipline to notice the difference between the record and the cost, and to act on what they found rather than simply celebrating the number on the dial. That discipline, as much as the speed itself, is what CC 7107 actually left behind.